Welcome to my video course on mastering ERTMS/ECTS signaling systems. Today, we're diving right into the incredible technological convergence that is actively reshaping the future of global rail networks. We're talking moving blocks, high-level automation, and the sheer unparalleled power of 5G connectivity. It's a massive paradigm shift, and I'm super excited to guide you through it. Okay, here's our roadmap for today. 1. The future of rail. 2. ETCS Level 3 spacing. 3. Automatic train operation. 4. The FRMCS revolution. And finally, 5. Bringing it all together. Let's jump in. Section 1. The future of rail. The need for evolution. To figure out where signaling is headed, we really have to face the music about our current infrastructure. There's an urgent global need to run more trains on the tracks we already have, and there's no way we're compromising on safety to do it. Expanding physical track? It's just too slow and way too expensive. So the fix absolutely has to be digital. It's actually wild when you think about how far we've come. Back in the 1850s, operators relied purely on visual trackside signals, literally flags and elevated lights. By the 80s, we got early automatic train protection, or ATP, automatically hitting the brakes if a driver blew past a red light. Moving into 2012 with the ERTMS rollout, we digitized a huge chunk of that. But tomorrow's railway? We're looking at a fully radio-based, completely automated network. To pull off that vision, the future of rail rests entirely on 3 main pillars, working in perfect harmony. First, how we safely space the trains on the track. Second, how we actually drive those trains. And third, the invisible communication networks tying the whole shebang together. All right, Section 2, ETCS Level 3 spacing, moving beyond fixed blocks. Let's look at that first pillar and see how we're completely rethinking train separation. So here's the absolute game changer. ETCS Level 3 introduces what we call a moving block. Historically, tracks were chopped up into rigid physical blocks, and only one train could sit in a block at a time. Level 3 tosses out the need for those physical track release devices. It calculates a safe, absolute braking distance on the fly, using the train's actual real-time position. Oh, and keep in mind, the industry is also actively developing hybrid Level 3 right now. It's kind of like a stepping stone to squeeze out more capacity using radio-based spacing before we entirely ditch all the trackside gear. Think about the difference here. With fixed blocks in ETCS Levels 1 and 2, the physical infrastructure dictates the space. You literally have to clear a fixed segment of track before the next train gets the green light. But with moving blocks in Level 3, the train itself becomes the center of the universe. Because these trains continuously shout out their exact position and integrity over the radio, they essentially carve out their own personal, dynamic, digital safety bubble as they speed down the line. So why does all this matter? It's all about capacity. By shrinking the physical gap between trains using these super precise digital movement authorities, operators can squeeze up to a massive 40% increase in line capacity. 40%. That's basically almost doubling your throughput without pouring a single ounce of new concrete for tracks. We're talking fewer delays and way more frequent trains for daily commuters. Section 3. Automatic train operation, the functional layer. Now that our trains are safely spaced out digitally, let's transition to actually driving them. Now, we have to draw a hard line between protection and operation. ATP, automatic train protection, which ETCS provides, is the safety net. It strictly watches your speed, draws protection curves, and slams the brakes if you make an error. But automatic train operation, or ATO, that is the functional layer doing the actual driving, accelerating, braking, stopping perfectly at the station. This is the exact tech unlocking those higher grades of automation, all the way up to ghost trains, fully driverless systems. But here's the catch. Automation doesn't happen in a vacuum. It requires a ton of data. Look at the jump from a basic grade 0 setup, which is mostly just voice and simple signaling, up to grade 2 automation, where ATO runs on top of ETCS Level 2. You need a serious data bump. The system strictly demands at least 95 kilobits per second per train just to keep those applications running smoothly without a hitch. Which brings us to a really fascinating technical bottleneck. If moving blocks and advanced ATO absolutely need constant, bulletproof data streams to function, how on earth do we support them when our current legacy railway networks are essentially running out of steam? And that brings us to Section 4, the FRMCS revolution, the next generation network. The answer to that critical question is pillar number 3, a complete and radical overhaul of railway telecommunications. For literally decades, railways have leaned on GSM-R, which is, let's face it, a 2G standard facing imminent obsolescence. To replace it, the rail community is building FRMCS, the Future Railway Mobile Communication System. This isn't just a minor patch, it's a massive, future-proof leap built squarely on 5G. It's custom designed to juggle the crazy data loads of ETCS and ATO, all while enforcing strict quality of service rules. Basically, it makes sure the life or death safety data always gets VIP treatment. What's amazing about this architecture is how FRMCS acts as the ultimate digital glue. It flawlessly bridges crucial applications like voice, ATO, and ETCS, funneling them straight through a standardized 5G transport layer. It takes all those isolated onboard systems and wires them into one massively integrated network. Of course, you can't just hit a massive upgrade button for an entire continent's railway network overnight. That's exactly why FRMCS has these brilliant multipath functions built in, letting it play nice with legacy GSM-R networks. During what's definitely going to be a complex multi-year transition period, a train can seamlessly chat with both the old 2G networks and the fresh 5G networks without dropping a single packet of critical safety data. And boom, we're back to that magic number. The FRMCS air interface is hard-coded to require a minimum application layer throughput of 95 kilobits per second per train. That specific benchmark guarantees every single train on the line has the dedicated, uninterrupted 5G bandwidth to run voice, advanced ETCS protection, and ATO all at the same exact time. It is literally the lifeblood of the modern automated train. Finally, Section 5, bringing it all together, a converged railway future. As we wrap up this explainer, let's step back and see how these three previously isolated tech pillars merge into one unified operational reality. This synergy here is just awesome to see. First up, ETCS Level 3 optimizes the track spacing, constantly crunching dynamic moving blocks. Then, the ATO layer grabs that movement authority and physically drives the train flawlessly inside that digital space. And tying it all together, FRMCS provides that invisible, lightning-fast 5G network, making all those split-second calculations and data exchanges between the train and the trackside possible. It totally flips the script on how we view rail transport. Will 5G-powered moving blocks and driverless trains finally unlock the true capacity limits of our global rail networks? Thanks again. See you next video.